This might seem like an odd topic in a programming course, but this is a game programming course. And so I think it behooves you to learn a little bit about a very old game and a very popular game, and maybe you've played it before. And that's called Dungeons and Dragons. It was created by I've flubbed his name already, Gary Gygax back in the 80s. And this is a game that's been around for a really long time. And there are a couple of reasons to really talk about it in this context. It's the basis for most video games, and pretty much all fantasy RPGs at some level borrow from the ideas in Dungeons and Dragons. So if you have anything with hit points, anything with experience, anything with magic levels, even ammunition, all of that was originally conceived and basically thought out by Gary Gygax and his work with Dungeons and Dragons, and it's evolved over the decades to become a fairly complicated game system. Back in the old days, though, we didn't have computer versions of the games. We just played using rule books, dice, and paper, and a lot of imagination. So it wasn't uncommon for people to show up with these great big file boxes full of books and character documents and all of this stuff that they'd come up with. And then, of course, we all had our polyhedral dice, which would range from 4-sided die all the way up to a 100-sided die, which is about the size of a softball. And so these were the implements of gaming back in the day before computers could really do a lot of this stuff. When I was a kid, we had computer games, but they weren't very complicated. The most popular ones were text-based games, and those were pretty cool. It was more like interacting with a story where it would give you some text, you would read it, and then you would type in a command, and then it would follow your commands. And it was pretty fun. But it didn't have cinematic graphics or animation or anything like that. So gaming has come a long way, but it owes a lot of that progress to some of these early games and the platforms and systems that we used to play with in order to create what we play today. So the way this would work is, again, you would create this character, and then you would play the character. That's why it's called a role-playing game. So you would pretend that you were that character, and people actually would go so far as to dress up like their character. I never did that, but we did have little lead figures, and we would paint the lead figures up, and we would have them around so that we could see what our characters would look like, and they were pretty cool. But there are people that go to great lengths to actually play their character and sort of get into sort of an acting mode where they become their character, and that's why it's called a role-playing game. So the character has physical and personal attributes that define who they are and what they can do. And this kind of goes back to our object-oriented lecture where we come up with different attributes called properties. And on our OOP lecture, we were talking about bicycles. Now we're talking about a game character. So the exercise is essentially the same. And I guess I'll forward the disclaimer that since the rules have evolved over the decades and I don't currently play Dungeons and Dragons anymore, I'm sort of relying on what I remember from when I was a kid. And so these are the really, really basic versions of the rules. If you're an avid D&D player or fan, please don't troll my website and tell me I got the rules wrong. That's not the point of this exercise. The point of this exercise is to give you, again, a well-defined system that you can build on and use for our work in our course. So let's do some basics. Every character has a name, they have an age, they have a race, they have a gender, they have a level that corresponds to how experienced they are, and we have a separate attribute for experience points. Basically, you start off at level 1 and you have 0 experience points, and then as you do things, you go through dungeons, you interact, you kill monsters, slay dragons, shoot orcs, do all that stuff and find treasure, maybe crack codes. It's not all monster killing, but a lot of it is. And so that's how you gain experiences. You go out into the Dungeons & Dragons world and you do things and you get points. And then as you gain more experience, you gain in levels. And for example, a level 4 character is pretty formidable. That's when things start getting really interesting. Before level 4, you have to worry about tripping, falling, and killing yourself, especially if you're a magic user. And that's a little nerve-wracking, but once you get to level 4, you can actually start doing some interesting things with your character. And then a level 10 character, if they live that long, is really formidable. They're a master at whatever they do. And then if you get to a level 20 character, frankly, you're probably cheating. But if you got to a level 20 character, it's considered a godlike character with a little g, so that we're not sacrilegious. And we're thinking Zeus here, not the creator of the universe, not that guy. All right, so there are different races in the original D&D, and of course they expanded over time and half-breeds and all of that crazy stuff. But again, we're limiting this to what I remember of the original rules, which is basically 1.0, and there were just a few of them. So we had humans, we had elves, we had dwarves, we had gnomes, which I never actually played, but they were in there, halflings, which are super tiny, like even smaller than hobbits, which were later added to the game as well, and ogres. So these are the different races that you can play. And then there are a set of attributes that every character has, and these have rules attached to them. So they have to be a range between 3 and 18 because we got them by rolling 3 six-sided dice 3 times, and then we would take the best score. So the attributes that you got were strength, intelligence, wisdom, dexterity, constitution, and charisma. That's why I write them down, because I'll forget them if I don't. And everyone has these scores, again, ranging from 3 to 18. And then every character has something called hit points. So this is how much damage you can take in combat before you die. And again, it can be anywhere from 1 hit point to, hundreds of hit points, depending on how experienced you are. As you gain in levels, you get more and more hit points, you can get stronger. So if you get to 0 hit points, you die, and negative hit points are even worse, but that's getting down into the weeds at that point. And then hit points are tied to your constitution. So that was one of the attributes that I mentioned a minute ago. That's one of the attributes I mentioned a minute ago that ranged from 3 to 18. And the higher your constitution, the more hit points you get. And as you level up, you get more hit points each time. So having a high constitution is a good thing. But there are some other things that will change what hit points you have, such as your race or your chosen profession. For example, magic users take hit point penalties. This is just the penalty that you take because you're about to learn how to throw fireballs and lightning bolts and do really, really amazing things. And apparently in the magical world of D&D, that takes a toll on one's constitution. So I guess that kind of makes sense. And then the other thing that makes sense is tiny races like halflings. You could accidentally step on one and crush him. They tend to have fewer hit points than giant races like ogres, who just naturally seem to be built like tanks. Okay, so going back to our attributes, I've already mentioned we get them by rolling 3 six-sided dice 3 times, and taking the highest score is the pretty common practice. That way you're not stuck with a really terrible score. The higher the score, the better. There are some modifications. So for example, if you're an ogre, you're considered ugly and mean, and so your charisma is modified downward, because the charisma is the measure of how attractive you are and how well you can engage in the social graces. And so ogres are traditionally thought to not be good at those kinds of things. The highest attribute will determine what your character's class is, and a class is pretty much the same thing as a profession. So for example, if you have a really high strength, then you're probably going to choose fighter as your class. And you can choose whatever class you want, but it makes sense to go with whatever your highest attribute is. If you're a magic user, you want a really high intelligence. If you're a cleric, you want a high wisdom. If you're a thief, you want a high dexterity. If you're a bard, now bard wasn't in the original set of rules, it came shortly after, but I wanted one for each of the different attributes, and that's what you do. If you have a high charisma, you're a bard, you run around the countryside with your lute and get people to give you things for free. Pretty much is how that works. And then the only other attribute that's left at that stage is Constitution, which I just said determines your hit points. So you want a high Constitution. So if you can get high scores in all of these things, that's a good thing. And just pick your highest one. But there's no class or profession associated with a high Constitution. All right, then we have attribute modifiers, which come into play at certain points. For example, if you have a strength of 18 and you're a fighter, you can roll a 100-sided die or 5 20-sided die if you don't have the softball, and that determines their maximum encumbrance. So it's one thing to be strong, but it's another thing to be able to carry a lot of stuff. And so that's what encumbrance is. And it's important for your fighter to be able to carry a lot of stuff. You want to be able to swing his sword really well, but you also want to be able to carry all the loot, all of the stuff that you find that you take back to the trading post at the end of the dungeon and sell for gold, and that allows you to buy more stuff for yourself. So having a party with a high encumbrance means fewer trips to town, and that's just nicer. If a character becomes a thief, there are some thieving abilities that you need to roll for. So this is specific to a thief, and these are just a few of them. A thief has a % chance to pick locks, a % chance to pick pockets, a % chance to spot or set traps, the % chance to hide in shadows. So these are just things that a thief can do, but they're unique to a thief. So these are attribute modifiers, and these are specific to particular classes. So based on what we've learned, we've already gone through a UML lecture, an object-oriented programming lecture. We're going to create a diagram for a Dungeons & Dragons character. And then, having completed the UML diagram, we're going to write some code in Unity that's defined by the UML diagram. And then as a final assignment, I'll turn you loose to do the rest of the properties. We're going to do a few in class, and then the rest you'll do on your own. And that'll be your first assignment. And we'll take a couple of swipes at this because it's important to sort of go try it and then come back and make some refinements to it. And that's just how the process works. Okay, after that, let's talk a little bit about refactoring. So refactoring is something that you do after you've taken a few swipes at things. So we mentioned we would do that. We would take a stab at it, write some code, then we would ultimately come back and make some changes to the way things work. And when you make a change to the way your code works, you're talking about refactoring. So you're not changing, you're not adding new features and capabilities, you're just going through and refining what you have. And you should always have a refactor step sort of figured into whatever time estimate that you've given your customers or your boss or whoever you're working with. Your team, or if it's just you, you should decide early that you're going to refactor as you go. So it's almost like making a rough draft for a written paper. You'll want to go through, and at some point you want to go through and correct all your mistakes, make something a little clearer, make something easier to understand, and just generally make your code better. And it even helps to sometimes have other programmers check your code if they're on the same team you are. That makes sense. But I'll go ahead and tell you what a few obvious refactoring opportunities are. So here are some that work really well at our current level. Remove any dead code. This is actually one of my biggest pet peeves, is when programmers leave code in that's no longer used. I can remember working for a company a number of years ago, and someone asked me to troubleshoot a problem, and I found a function or a method inside of a class, and it was named, along the lines of whatever wasn't working, and this has to be it, and I'm digging around in this code and make changes, recompile, try it. It doesn't seem to have any effect, and after 10 or 15 minutes of this, I finally put a tool on it called a debugger, which allows me to set a little point in time where it'll stop and show me what it's doing at that particular point in time in the program. We'll talk about debuggers another time, but if you've never used one before, they're very useful and handy and essential tools for any programmer. The debugger never tripped, which told me that particular piece of code was no longer used. And so I had to track down the person that wrote the code, and he said, oh yeah, I moved all of that to this completely different class way over here in this other location in the program, but I never took the old code out because I was afraid that when I moved it, I would break it, and so I wanted to be able to, easily switch it back to the old code. And that's bogus. We have systems that will help you roll back changes. They're called revision control systems. And again, that's a talk for another time, but we have tools that manage this for us. We don't need to do this practice of, oh my gosh, I'm afraid to take anything out. So if there's a piece of code that you're not using anymore, and certainly what he should have done is once he proved that it was working in the new version, he should have gone into the old version and removed it. What you're doing in this case is you're just wasting people's time and you're confusing other programmers on your team. So remove any dead code. And then the next thing that you want to do is make sure you follow consistent conventions for your variables and function names. Make sure that everything's easy to understand. So they should have nice descriptive names. I shouldn't have to guess at what a variable is holding or what a function does. It should be right there in the name. When you write functions and we get into object-oriented programming, you're talking about methods. They're essentially the same thing. Each function or method should only do one thing. If you've got a function or a method that does 20 or 30 things and it's really long, then you've got what's called a God function, again with a little g, and that is what we call an anti-pattern. An anti-pattern is a bad thing. So if you have this great big function and your whole program is in one function and everything happens in there, that's a God function and you want to get rid of that. You want to break it out into smaller functions. So a function should really only do one thing. Now it's okay if your main function, obviously is going to be calling all these other subordinate functions, but you do want things to be broken out, and you shouldn't have a function that does a lot of different things. So that's another opportunity for refactoring. And then anytime you find yourself copying and pasting code from one location to another, that's another refactor opportunity. You should feel guilty when you do this. If you're copying and pasting something from one place to another, you should feel ashamed of that. It's like, oh my gosh, what am I doing? You're repeating yourself is what you're doing. And we have an acronym in programming called DRY, D-R-Y, which means don't repeat yourself. If you find yourself copying and pasting code, what you should really do is extract whatever you're copying and pasting out into a function or a method all its own, and then you should call that function from the different locations where you're copying and pasting to and from. So those are a few really obvious refactor opportunities. And we have some capability in our IDE to do this. So we're going to take a look at some refactoring tools in our IDE, and that's either going to be Visual Studio or MonoDevelop, depending on how well equipped we are from semester to semester. So we'll take a look at those. And I'll show you how to do this sort of copy and paste fix where we're not doing that anymore. And when we're finished, you'll want to go ahead and submit your exercise and get some points, but you do want to hang on to this code because we're going to be using it in other exercises and other labs. So this is something that's reusable. Hang on to it.